Welcome. I am R. Geetha, lecturer, PG and Research Department of Physics, Sita Lakshmi Ramaswamy College, Tiruchirappalli. In this video, we are going to see about the fundamentals of flip-flops in digital electronics. Digital electronics deals with the electronic manipulation of numbers or with the manipulation of varying quantities by means of numbers because it is convenient. In today's digital system deals only with the number 0 and 1 because they can be represented easily by on and off within a circuit. Latch. A latch is a special type of logic circuit. The latches have two stable states as low state and high state. It is a bistable device with inputs that remains in a given state as long as the power is applied and until input signals are applied to cause its output to change. Due to these states, latches also referred to as bistable multivibrators. A latch is a storage device that holds the data. A bistable device is a circuit having two stable states. The latch stores one bit until the device set to 1. It may either 0 or 1. Latch. A latch is a temporary storage device that has two stable states. It is the basic form of memory. SR latch. The set-reset latch can be constructed from NOR gates or NAND gates. With the NOR gates, the latch responds to active high inputs. With the NAND gates, it responds to active low inputs. Latch circuit is a circuit which locks its output when a momentarily input trigger signal is applied and retains that state even after the input signal is removed. This state will remain indefinitely until the power is reset or some external signal is applied. Output. Q and Q bar. Q denotes the present state of the memory device, that is, the state at the time of input signals are applied. Q bar denotes the next state, that is, the new state assumed by the device in response to the input signals. Timing consideration. Propagation delay, minimum pulse width, setup and hold time. These three plays a vital role while considering latches and flip-flops. Propagation delay. The propagation delay or gate delay is the length of time which starts when the input to the logic gate becomes stable and valid to change to the time that the output of that logic gate is stable and valid to change. Pulse width. The pulse width is a measure of the time between the leading and trailing edge of a single pulse of energy. Minimum pulse width. The minimum pulse width verifies that a clock high or low pulse sustains long enough to qualify as a recognizable change in the clock signal at the register clock pin. A failed minimum pulse width check indicates that the register may not recognize the clock transition. The major difference between duty cycle and pulse width. Duty cycle is the percentage of the ratio of pulse duration or pulse width to the total period of the waveform. It is generally used to represent the time duration of pulse when it is in high state. Why latches are not suitable? Latches circuit are not suitable in synchronous logic circuit. When the enable signal is active, the excitation inputs are gated directly to the output. Thus, any change in the excitation input immediately causes a change in the latch output. The problem is solved by using a special timing control signal called a clock to restrict the time at which the states of a memory elements may change. This leads us the edge-triggered memory elements called flip-flops. Flip-flops are formed using logic gates. Flip-flop are basic building blocks in the memory of electronic devices. Each flip-flop stores one bit of data. They are also called as a sequential logic circuit. Flip-flop is a synchronous bistable device. Output changes state at a specified point on a triggering input called the clock. Change state either at a positive edge or at a negative edge of the clock input signal. And clock is usually represented as a square wave. Flip-flop timing. Setup time and hold time. To achieve a satisfactory operation of a latch, constraints are normally placed on the time intervals between the input changes. The minimum time the signal input must be held fixed before and after latching action is called setup and hold time. The interval before the active transition of the clock signal during which the data must be maintained. Hold time, the time interval after the active transition of the clock. Positive and negative edge triggering. When there is a transition from 0 to 1, it is named as positive edge triggered. And when the clock pulse make a transition from high to low, that is from 1 to 0, it is termed as a negative edge triggered. A signal edge is a transition of a digital signal from low to high or from high to low. A rising edge or positive edge is a low to high transition. A falling edge or negative edge is a high to low transition. The basic difference between latch and a flip-flop is given here. Latches do not require clock signal. Flip-flop have clock signal to change its state. A latch is an asynchronous device. A flip-flop is a synchronous device. Latches are transparent device, that is, when they are enabled, the output changes immediately if the input changes. A transition from low to high or from high to low of a clock signal will cause the flip-flop to either change its output or retain it depending on the input signal. A latch is a level-sensitive device. A flip-flop is a edge-sensitive device. Latches are simpler to design as there is no clock signal. When compared to latches, flip-flops are more complex to design as they have clock signal and it has to be carefully routed. The operation of a latch is faster as they do not have to wait for any clock signal. Flip-flop are comparatively slower than latches because of a clock signal. The power requirement of a latch is high. The power requirement for a flip-flop is more. As a latch works based on a enable signal, the flip-flop works based on the clock signal. There are basically 4 different types of a flip-flop. They are SR flip-flop, JK flip-flop, D flip-flop, data or delay flip-flop, and T flip-flop, toggle flip-flop. Flip-flop is a circuit that maintains a state until directed by input to change the state. A basic flip-flop can be constructed using 4 NAND or 4 NOR gates. The set reset flip-flop, JK flip-flop, D flip-flop and T flip-flop are given here. There are majorly 4 types of flip-flop, with the most common one being SR flip-flop. This simple flip-flop circuit has a set input S and a reset input R. In this system, when you set S as active, the output Q would be high and Q bar will be low. Once the output are established, the wiring of the circuit is maintained until S and R go to high or the power is. The NAND gate SR flip-flop, we can implement the set reset flip-flop by connecting 2 cross-coupled 2-input NAND gates together. In the SR flip-flop circuit, from each output to one of the other NAND gate inputs, feedback is connected. This simple flip-flop is basically a 1-bit memory bistable device that has two inputs, one of which will set the device and is labeled as S, and the one which will reset the device is labeled as R. Then the description SR stands for set reset. SR flip-flop is a gated set reset flip-flop. The S and R input control the state of the flip-flop when the clock pulse goes from low to high. The flip-flop will not change until the clock pulse is on rising edge. When both S and R are simultaneously high, it is uncertain whether the outputs will be high or low. The function table for SR flip-flop is given. When both the inputs are in zero state, it will retain in its previous state. When the inputs for S and R are 0 and 1, the output Q will become 0, that is reset condition. When the outputs for S and R are 1 and 0, the output Q changes its state from 0 to 1, that is set condition is maintained. When both the inputs for S and R are 1, the output becomes 1, that is Q, and Q bar becomes 1, that is not allowed or forbidden condition. Uses of SR flip-flop. It is mainly used to store data or information. Wherever operations, storage and sequencing are occurred, these signal circuits are used. They are also used for excising control over the way the circuit has to function, like for changing the operation of a circuit to a different state. The various types of flip-flop are being used in digital electronic circuits, and the applications like a counter, frequency dividers, shift registers and storage registers. Conclusion. A flip-flop or latch is a circuit that has two stable states and can be used to store one state of information. A flip-flop is a bistable multivibrator. The circuit can be made to change state by signals applied to one or more control inputs and will have one or two outputs. It is basic storage element in a sequential logic circuit. Flip-flops and latches are fundamental building blocks of digital electronic system used in computers, communication and many other types of systems. Thank you.